How do ice-ocean interactions affect polar glacier fronts? Imagine a giant icy wall standing at the edge of the ocean, constantly changing shape and size. That's what happens at the front of glaciers in polar regions. These interactions between ice and ocean water are key to understanding how glaciers behave and change over time. When ocean water touches the underside of floating ice shelves or the front of tidewater glaciers, it causes melting from below. Warmer ocean water, especially in recent years, has been melting these ice fronts faster. This thinning weakens the ice and can make glaciers retreat more quickly. At the boundary where the ice meets the ocean, a thin layer forms that controls how heat and salt move between the two. This boundary layer is like a tiny barrier that decides whether the ice will melt or refreeze. If the ocean water is warm, it speeds up melting at the glacier front. This process thins the ice, making it less stable and more likely to break apart. When ice shelves thin or collapse, they lose their ability to hold back the glaciers behind them. This causes the glaciers to speed up and discharge more ice into the ocean, raising sea levels. Ocean currents also play a big role. Cold, dense water sinks and moves around the glacier base, but when meltwater from the ice mixes in, it becomes less dense and rises. This process creates convection, which stirs up the water and can increase melting. Strong currents can shear along the ice base, carving out channels and accelerating melting in specific spots. These currents are influenced by the shape of the ocean floor and the presence of sea ice. The grounding line, where the glacier starts to float, is very sensitive to ocean conditions. When warmer water reaches this point, it melts the ice from below, causing the glacier to retreat. This retreat reduces the support the ice shelf provides, leading to faster glacier flow and more ice entering the ocean. In some parts of Antarctica, like the Thwaites Glacier in the Amundsen Sea, rapid thinning and retreat are linked to high basal melt rates caused by warm ocean water. As the ice shelf loses contact with the bedrock, it becomes more vulnerable to collapse. Sea ice also influences these processes. When sea ice covers the ocean, it insulates the water and limits heat exchange. Less sea ice means more ocean mixing and warmer water reaching the glacier front. Changes in sea ice cover can either slow down or speed up melting, depending on how they affect ocean circulation and temperature. Understanding these interactions helps scientists predict how glaciers will respond to climate change. As ocean temperatures rise, the melting at glacier fronts will likely increase, leading to faster ice loss. This process is a major factor in global sea level rise and affects the overall stability of polar ice sheets. Combining observations from satellites, field studies, and computer models allows scientists to better forecast future changes. In the end, ice-ocean interactions are like a delicate dance that controls the fate of polar glaciers. They determine how fast ice melts, how glaciers retreat, and how much ice ends up in the ocean. These processes are vital to understanding the future of our planet's climate and sea levels.